What's up, guys? It's Mr. Bringle, and today we are going to talk about interpreting graphs in terms of acceleration. So let's zoom in a little bit here and get started. We've been given a position versus time graph here. We can see position here, we can see time here, and this line is obviously curved. So a couple things that we need to remember is that the slope of a position versus time graph is going to tell us the velocity of the object. So we know how fast the object is going based on how steep the slope is, right? If it's steep, it's fast. And if it's flat, it's going to be moving slowly. Okay, so that will help drive some of our decision making here for these questions. The first question says, where on the graph above is the object moving slowly, and how do you know? Now, I would like for this to be a discussion, so if you're completing this at your table, go ahead and pause the video for a second and discuss that question with your table mates, come to a consensus, and then you can restart the video. I will go ahead and move on right now. So when this says where is it moving most slowly, I know that I need to be looking for places on the graph where the line does not have very much of a slope. It's flat. Okay, so I see obviously a slope right here, but that slope is getting flatter, 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 flatter until we get to point B where it seems the flattest. And then it starts getting steeper, steeper, steeper as it goes down here. And then it starts to flatten out again by the time it gets to F. That's the flattest point on this half of the graph. And then it gets steeper again. So the points that we're interested in here would be points B and points F because the slope is the most flat at that point, indicating that the object is either not moving or is moving very slowly. So B and F, and the reason for that would be slope at those points is most flat. Okay, now let's go ahead and move on to the second question, which says, between which points is the object speeding up? How do you know? Again, please pause the video, discuss with your table, come to a consensus, and then restart the video. I will go ahead and move on right now. So when we're looking for something that is speeding up, what we're really looking for is where is the slope going from flat to steep. So basically, where is it getting steeper over time? And there will be two places that we want to look for here. If we start at point A, we can see we have a pretty steep slope right here, but as you move from A to B, the slope is getting flatter. So that's not going to be what we're looking for. However, since the slope is most flat at point B, we can look at the slope from B to C and see that it's, even though it starts flat right here, it becomes steeper as it goes to C, right? So B to C is one of the points. B to C is one of the points where it gets steeper, and therefore we know it is moving faster. Now be careful here because often people will include this segment right here from C to E. And even though this is the steepest part of the graph, it's not getting steeper as you go from C to E. This is actually a line that has a constant slope here from C to D and a constant slope from D to E. That indicates that the velocity of the object is not changing at that point or between those points. So again, we need to be looking for a place where the slope is actively getting steeper. And so B to C is the first one, and then we will have to continue on here to find the second one. After point E, we can see, even though it was steep here, it does start to get flatter, so that is not going to be the location we're interested in. But because point F is the flattest point on this half of the graph, and then it goes to point G, and this slope is getting a lot steeper from here to here, right? So slope is more like this at point F, and it's like this at point G. Point G is obviously steeper. So that would be our second location, would be from F to G. And the reason for this is slope gets steeper, or more steep. There's a reason I don't teach English. Okay. Between which points is the object slowing down? So we've kind of already talked about that in our in the problem that we just did. Where is it slowing down? So I'll kind of go back through that, but let's go back to our graph. And when we're looking for something that's speeding up, if we're looking for the slope gets steeper, then we're doing the opposite thing for where the object is slowing down. We're looking for places where the slope is getting flatter over time. So we do want to focus on points B and F, since those are the flattest points. And we're basically just looking for where does the slope does it flatten out as it goes from A to B, or from B to C? Obviously, we already chose B to C as a point where it's speeding up. So we can see here that the slope at point A is pretty steep, but then when it goes to point B, that is flattening out up here. And on the other side of the graph, after point D here, we can see that point E is pretty steep slope, and then it does flatten out as it goes to point F. So those are going to be our locations there, A to B and E to F. And again, A to B, E to F, and the reasoning for this is because the slope gets less steep or becomes more flat as you go from the first point to the second one. Okay. The last question here, it says, where is the object changing direction? And how do we know? So again, please pause the video. I forgot to say that on question C, but pause the video, talk about it, get an answer, and then come back and restart the video. Direction on this graph, which is not something that we put up here, things to remember, but the direction that the object is moving is going to be related to where or which direction the slope is. Is it a positive slope or is it a negative slope? We can see from the start to point B, we do have a positive slope here. And then from point B to point F, we have negative slope. And then as it goes from F to G over here, again, we have a positive slope. So the most common wrong answer here is to answer point D, because people look at that and they say, oh, well, it's changing sides of the graph. It's going from the positive half of the graph to the negative half of the graph. And so they think, oh, this is where we're changing direction. But really, if the object is moving in the positive direction, it has a positive slope. If the object is moving in the negative direction, it has a negative slope. So we're looking for the point where the slope changes from positive to negative. And that location, or negative to positive. And as we can see here, the point where it switches from positive to negative would be at point B. It's positive on this half, it's negative on this half. And then at point F, we've got negative on this half and positive on this half. So B and F would be the locations where this object is changing direction. Again, to revisit point D here and why that is not correct, if we look at points C, D, and E, so just going from right here to right here, we can see that that slope is negative at all times. Right here during this entire time from C to E. And really from point B all the way to F, we have a negative slope. So that indicates the object's always moving backwards during that time. So again, our answer here, we're just going to put B and F, and our reasoning there is that slope changes from positive to negative, or negative to positive. Okay, so that will conclude acceleration worksheet number 4. This is really designed to be more of a discussion than anything else. So hopefully you were able to discuss some of this with your table mates, and maybe you got some things right, maybe you got some things wrong, but I hope you learned something along the way.